Okay, so all semester I've been trying to drive home this point of how important the synapse is. And sure enough, here we are talking about the effect of drugs. And there's no greater area in the brain or the nervous system that drugs affect than right at the synapse. And these next two slides are critical. This one here is presynaptic drug action, and then another one, the next one, is postsynaptic drug action. Please know these 8 steps, and I'll point out some examples. You don't have to know all of them, but I'll point out the ones you really need to know, okay? So, anyway, the first one, synthesis of neurotransmitters. So, there are drugs that can block the synthesis of neurotransmitters or the formation of neurotransmitters. And if you do that, that's going to have a significant effect. This drug right here, alpha methylparatyrosine, it affects the synthesis of serotonin. Now, now some of these drugs we see up here, they were created by scientists in order to mess with the system to try to figure out how the system works. So these aren't drugs that you would normally give to a patient, okay? But this drug right here affects the synthesis, and so if you can't form serotonin, there's going to be some issues associated with that. Colchicine was another drug created by scientists that affects axonal transport. So here's the transport coming from the cell body. It can disrupt that. And that means that the neurotransmitters are not going to be put into the vesicles and not going to be released into the cleft. Number 3, conduction action potentials, TTX. TTX blocks voltage gated sodium channels. This is the poison from pufferfish. Okay, if you're snorkeling, do not pet a pufferfish. Okay, you will die, right? Because it blocks all voltage gated sodium channels, stops your action potential, you stop breathing and you die. Okay, so that's one I definitely need you to know. Storage of transmitters into vesicles. Okay, reserpine is another drug invented by scientists, okay, that we tweaked, and it has to do with whether these components get packaged into the vesicles or not. Again, if they're not packaged, they can't be released, they can't do their job. All right, let's talk about number 5, release of synaptic transmitters. Okay, so we have amphetamine. We can also take cocaine from down here and put it in here as well. Amphetamine and cocaine, these both cause increased release of norepinephrine and dopamine. Okay, amphetamine and cocaine. So please know those. Increased release of norepinephrine and dopamine. Now, black widow spider venom, I don't know if you realize, but we live in an area where black widows were all over the place. Okay, don't reach under your barbecue grill and try to turn it on without checking to make sure there's not a big old black widow there waiting to bite you. Black widow venom causes a massive release of acetylcholine. It probably won't hurt a grown adult, but it could be damaging to a small pet or a toddler, something like that. Okay, but again, massive release of synaptic transmitters. Number 6, modulation of transmitter release by presynaptic receptors. So we have receptors here, and we can tweak those. It turns out this process is a little complicated. You release, and then there's modulation. Both caffeine and alcohol. Let's add alcohol right here. Alcohol can affect presynaptic receptors. Okay, and then number 7, inactivation of transmitter reuptake. We talked about this earlier. You see this process of release and then reuptake back into the cell. Well, cocaine and amphetamine not only increase the release, but they block the reuptake. So that means there's a double bang for your buck there. Okay, more neurotransmitter release and then not taking up, so it's intense. The other thing is Prozac right here. We talked about it. Blocks reuptake, and so it allows serotonin to have a little more bang for its buck. Number 8, blockade of neurotransmitter degradation. So we talked about reuptake in that you see this receptor-mediated reuptake right here. The neurotransmitters bind these surface receptors and they're taken back in. We didn't really talk about this much. It's not that important, but that's one way. I talked about it briefly about how the neurotransmitters just go through the transporters back into the cell. The other way it can happen is if enzymes break them down into smaller parts and then they're taken back up. This is where monoamine oxidase, the MAO, is the enzyme that does that for all the monoamines, and the inhibitors block that, right? And we talked about blocking all those can cause increased side effects. So we can blockade neurotransmitter degradation and prevent reuptake this way via MAO inhibitors or sadly, via chemical biological weapons. Sarin gas is classic. So acetylcholine is released into the cleft. There's an enzyme called acetylcholinesterase that breaks it down and brings it back up into the cells. Well, sarin gas, a horrible biological weapon, prevents acetylcholinesterase from doing that. So the ACH is left in the class. What happens is muscles paralyze. They clamp, they paralyze, and people suffocate on the battlefield. It's a pretty sad state of affairs. Anyway, that's how drugs can affect our bodies at the presynaptic level. Okay, there's 8 different sections. Next, we'll talk about the postsynaptic level.